Today we are going to discuss some important theorem which are helpful to solve the practice set 3.5. Okay? Now see here, the theorem is theorem of angle between the tangent and the secant. Here BC is tangent and here BA is secant. BC is tangent in all the figures. Okay? Now see here, given if an angle has its vertex on the circle, here if you will see, this is the angle here, this is the angle on the circle. Okay? Its one side touches the circle, one side touches the circle means it is a tangent, and the other intersect the circle in one more point, and the other intersect the circle at one more point, that is at A. Here also. Then the measure of the angle is half the measure of its intercepted arc. Means measure of angle, here I am writing measure angle ABC is half the measure arc ADB in all the three figures. Okay? Here this ABC is half of ADB, here ABC is half of AD, and this is as per the tangent secant theorem. The same theorem in a different alternate way given the angle between the tangent of a circle and a chord drawn from the point of contact is congruent to. Now see here, this is the tangent BC and BA is a chord. Okay? Drawn from the point of contact is congruent to the angle inscribed in the arc opposite to the arc intercepted by that angle. Now see here, this angle intersecting this arc, okay, and opposite to this arc is BEA, in which a angle AEB is inscribed. Okay? Therefore, this angle, here this angle is equal to this. As this angle is also from the inscribed angle theorem is half of the arc intercepted, that is ADB. Here it's given indirectly, means angle, measure angle ABC is equal to measure angle AEB, because both the angles are half of the measure arc ADB. Okay? Clear? Now the next theorem is converge of theorem of angle between the tangent and the secant. Means the previous theorem, converge of that. A line is drawn from one endpoint of a chord of a circle. Means here PQ is a chord and a line is drawn from one end of the chord. And if the angle between the chord and the line is, the angle between the chord and the line is, this angle is half the measure of arc intercepted by the angle, this angle is half of this arc, PSQ, then that line is tangent to the circle. Then if this angle is half of this arc, then this line means TR or QR is the tangent. Now see, if this angle PQR is half of the measure R, PSQ R angle PQT is half of the arc PU, half of the arc PUQ, then this line PR is the tangent. Okay? Means you can use this theorem to show that this line is a tangent. That is from the converge of theorem of the angle between tangent and secant. Means converge of tangent secant theorem. Okay? Now the next is theorem of internal division of chord. Two chords intersecting inside a circle at point E. According to this, now see, suppose two chords of the circle intersect each other in the interior of the circle, then the product of the length of two segments of one chord is equal to the product of the length of the two segments of the other chord. Now see here, what are those two segments? One segment here, I am going to take, now see, one segment is this, second segment is this one. Okay? Means you can say AE into EB is equal to how much? That is CE into E. CE into E. Okay? Means here this two parts of the chord, product of these segments is equal to the product of the two segment of the other chord. Okay? This is here. This is used to find out the length of the chords or the segment of the chords. Okay? And that is the theorem of internal division of chord. The same is for the external division. Here now see, the theorem of external division of chord. If the secant containing chord AB and CD of a circle intersect outside the circle. Now see here, these are the in the form of secant, that is chord AB. Here in this secant and chord CD here in this secant. Okay? And they intersect at point E outside the circle, then according to this, AE into, now see here, this you have to take the segment from the point of intersection, means AE and BE. Okay? Here CE and DE, not like this AB and BE. You have to take from the point of intersection AE into BE is equal to CE into DE. Here that is given. Okay? And this is also used to find out this chord's length or the segment here AE and CE. This is the external division of chord. Okay. Now the last theorem, tangent second segment theorem. Now see here, point E is the exterior of a circle. Here point E is the exterior. A secant through E intersect the circle at point A and B. Circle at point A and B, and a tangent through E. And now see here, this is the secant intersecting the circle at point A and B, and a tangent through E touches the circle at E. The circle at point T. Then here now see here EA and EB. Here also you have to take from the point of intersection, that is EA into EB is equal to ET square. You can use this formula to find out the EA or EB or ET or AB also. Okay? Then this is the tangent. When you are using this formula, you have to write there, that is tangent second segment theorem. Okay? Using all these theorems, we are going to solve the practice set 3.5. Okay? We are going to solve next the practice set 3.5 of practice set 3.5. See here, what is given in figure 3.77, raise PQ touches the circle at point Q. Here PQ touches the circle at point Q, and PQ is given here 12, PR is given 8, asking about PS from here to here and RS. Okay? First we will write here that ray PQ touches the circle at point Q. Okay? It means that PQ touches the circle only at one point. Therefore, this is the tangent. Therefore, we are going to use here. Therefore, we are going to use that PQ square is equal to PS into PR. PS into PR. Here we will write here the tangent second segment theorem. Okay? This is tangent second segment theorem. From that we can write like this. Here its value is given, PQ is given, that is 12 square. PS we have to find out, and PR is given equal to 8. Therefore, here PS into 8 here. This is equal to square of 12, that is 144. Therefore, PS is equal to 144 upon 8. Okay? Now 8 1 ja 8 and 8 8 ja 64. That is PS is equal to 18. You can write PS because here unit is not given, 18 unit. Okay? You can write this. Therefore, PS is equal to how much? 18 unit. Now see, asking about RS also. This RS. RS is how much? That is PS minus PR. And that we are going to write here that PS is equal to PR plus RS. Okay? PS is how much? We find out that is equal to 18. PR is 8 and therefore RS is equal to how much? 18 minus 8. Therefore RS is equal to 10. Again we will write here RS is equal to 10. Okay, this is your final answer. Now after this, now see here first again sheet means from only using the tangent second segment theorem, because this is the tangent and here this PS is a second. Okay, now the next is the second problem here. In figure 3.78, this is the 3.78, chord MN and chord RS intersect at MN and RS intersect at D. Means that is the internal division of chord. Okay? If RD is given, here this RD is given from here to here, how much? This is 15. RD is given, DS is also given, how much? 4. DS is given, how much? It is 4. And then MD is given equal to 8. This here MD is given and asking about DM. Okay? Then here chord MN and chord RS intersect at point T. Therefore, we will write here that directly we are going to write here the things which are first given. Chord, we are going to write here chord MN and RS intersect internally. Okay? RS and intersect internally. Therefore, what will happen? Means MD into dm is equal to, means from the point of intersection, MD dm is equal to RD into ds. Okay, means you have to take the distance from point D. Okay, now see, the value is given, MD is 15, dm we have to find out, and RD is, sorry, MD is given here, MD is given 8, okay, RD is given 15 and DS is given 4. We have to find out dm here, that is 8 into 15 4 ja 60. Therefore dm is equal to 60 upon 8. dm is equal to 7.5. Okay, 7.5 we get here, this dm, that is 7.5 unit. Okay, after this, here we are having the second, that is telling that if radius is 18, here this total distance radius is given 18. MD is given 9, from here it is 9. Okay, and dn is given 8. This is given 8. Asking about ds. dn is given, asking about ds. Now see here, as I told you that we can take only the distance from here, from D, means we can take MD into dn, RD into ds. But here RD is not given and ds is not given. Then here we will consider, we will let dx is equal to x. Okay, and then further means we will consider here this value is yes. Then what will happen? RDX will be 18 minus x. Okay, here RD will be 18 minus x, means we are going to use this. Understood? Okay, now see, we are going to write here MD into dn is equal to RD into ds. Here we will, the second part of this, as I told you, we will consider. Okay, first thing, the value of MD is given how much? 9. dn is given, that is 8, and here RS is given, that is 18. Okay, here we will consider, let that is ds is equal to x. Therefore, Therefore, here RD will be 18 minus x. Okay. Now we will use the theorem here, that is MD into dn is equal to RD into ds. That is the internal division of chords. Okay, internal division of chords. Here its value is given 9, dn is given 8, rd we have to find out here, means rd is 18 minus x, and here ds is x. Okay. Then here 9 8 is 72. It will be 18x minus x. Okay. Now we will take it on one side. It will become here. Now see here. We will take this term on one side. This will become a quadratic equation. That is x square minus 18x plus 72, that is equal to 6. Now we will solve it. As you know, the quadratic equation, 12 6 ja 72. Therefore 12x minus 6x plus 72, that is equal to 0. Here on the next page we are going to write here x minus 12, here it is minus 6, x minus 12 is equal to 0. Therefore, x minus 12 is equal to 0, or first we will write here x minus 6, take this common, x minus 6, this is equal to 0. Therefore, x minus 12 is equal to 0, or x minus 6 is equal to 0. Therefore, x is equal to 12, or x is equal to 6. Here, x we have considered, that is ds. Okay. Then if ds is, now see, if ds is 12, then rd will be 6, and if ds is 6, rd will be your 12. This will be the answer. Okay, means for the value, now see here, I am going to explain you on here. If this value will be 6, this value will be 12 minus 6, that is 18 minus 6, that is 12. And if this is 12, then this value will be 18 minus 12, that is equal to 6. These are the values of ds. Okay, is there any problem?